All right, are you still using 555 timers just to make a clock? Well, you're using the wrong chip. Look, you need one resistor and one capacitor and you're done. All right, you're done. You can get a nice clock. All right, that's all you need. One resistor, one capacitor, and a magic chip. So what is this magic chip? Well, there was the 555 and then there was some other 5 things, and this is a 567. Okay, it's an LM567 or any 567. They're all the same. 67. They're sort of invented to be a tone decoder, but if you read the data sheet, it also says precision oscillator. And it has an oscillator, it has a VCO circuit, and it has a phase comparator and stuff. It's got a bunch of stuff in it, but you can use it just as an oscillator, and you can see that here. I've got a 1K resistor and a 0.01 microfarad capacitor, so that's pretty basic. And let's see, we are, what are we measuring? 14.4 kilohertz. So there you go. We could take a look at that's pin 5, and this is pin 6. So pin 6 has the integrate up, integrate down, you know, and so that sets the clock. So you could also use that signal if you wanted to. And just like the 555 timer, it has the ability to have, you can either use the pin that I'm on, or you can use pin 8, which is an open collector. Okay, so we need a pull-up resistor. I have to add one more part for the pull-up. So I'm going to add another 1K resistor to pin 8, and my fingers won't let me do this. That's why we have little pliers. There we go. All right, so now I put a 1K pull-up on pin 8, so that's open collector, so we should be able to take a look at that now. And I'm going to change it a bit here. When you use open collector, you have to kind of add an extra wire onto it here. And I need to trigger on, we can go up, but we need to trigger on channel 2 because that's the probe that I'm using. So there we go. We'll turn off 1 now. So there we go. So that's the open collector, and it's working just fine. And there's another cool trick you can do. I'm going to do another wire change here. And there we go. You see that little spike down there? So you can create little pulses instead of create 1 microsecond pulses at 14 kilohertz. So yeah, it's a quite versatile little chip. So what I did was I shorted out pins 5 and 2, and that makes it do the pulse generating thing. And if you short out pins 1 and 5, then it's just regular oscillator from there. So anyway, I encourage people to run out and get a LM567. They're reasonably priced. They're not like 555s. I think they're a little bit more expensive and maybe a little bit harder to find. But if you really want to just use 1 resistor and 1 capacitor and have a timer, there you go. And you can do a bunch of other stuff with them too. All right, so we have a timer now. Let's see if we can do a particular measurement here on the, let's see, it's not in there. It's not in there. It's over here in measure. Yeah, measure, analyze, jitter. So if you want to figure out if these clocks are jittering or not, you can do this in a scope. And we're going to turn it on, and we are going to measure, and we're going to turn the histogram on, and we are going to wait. All right, so what the What this scope is doing is it's measuring the jitter of the clock and collecting that data. It says jitter analyzing, and as it's analyzing, it's creating this purple histogram. And the units for the histogram are down here. And so we'll let it build up here for a while. Okay, it's been running several minutes, and you can see it's building up this histogram. And the units of the histogram are here. It might be hard to read. It's 20 nanoseconds per division, so it's about plus or minus 1 division. So about plus or minus 20 nanoseconds. So that's the jitter of the edge is plus or minus 20 nanoseconds. So pretty cool measurement for the scope.